In-class activity 14B, one-way ANOVA. Again, to watch this video, have this lesson note probably printed and ready with papers and pens in front of you, so you can use them and write and work with us as we go through the video. Number one, do certain college majors spend more time studying than others? According to a study done by the National Survey of Student Engagement, on average, college students spend 17 hours a week preparing and studying for their classes. Do you think students with different majors, specifically arts and humanities, STEM, education, and business, differ in the mean number of hours they spend preparing for class each week? Why or why not? Let's say it again. Do certain college majors spend more time studying than others? According to a study done by the National Survey of Student Engagement, on average, students spend 17 hours a week preparing and studying for their classes. Do you think students with different majors, specifically arts and humanities, STEM, education, and business, differ in the mean number of hours they spend preparing for class each week? Why or why not? Answers will vary, but they are probably different, either because the majors are different or because the individuals are different. But it's likely that the hours spent would not be identical. The objective for this activity, you will understand that one-way ANOVAs are used to compare two or more means. You will be able to perform a one-way ANOVA using technology and interpret the results of a one-way ANOVA in context. This is important. Okay. 2, part A. What is the question posed in problem 1? The question is, do students with different majors, specifically arts and humanities, STEM, education, business, differ in the mean number of hours they spend preparing for class each week? How many groups are we comparing? There are 4 groups. 1, 2, 3, 4. So the answer is 4 groups. C, define what each parameter represents. Mu1 is the mean number of hours spent preparing for class for arts and humanities majors. Mu2, mean number of hours spent preparing for class for STEM majors. Mu3, mean number of hours spent preparing for class for education majors. And Mu4 is for business majors. With those notations, we can write the null and alternative hypothesis. The null hypothesis, H0, is mu1 equals mu2 equals mu3 equals mu4. Alternative hypothesis, at least 2 of the means are different. Now let's look at problem 4. Suppose the college randomly sampled 12 students from each of the 4 major departments at the college and asked them how many hours a week they spent studying and preparing for class. The data is given in the table below. So this is arts and humanities, STEM, education, and business. We will now use technology to find the summary statistics for each group. These will be the same steps we use to run an ANOVA. For this activity, we will assume the data meets the assumptions for an ANOVA. We will learn about these assumptions for ANOVA in the next lesson. For now, first step, we go to the ANOVA one-way app at the following link: https://artsofstats.com/webapps. In the enter data box, we choose provide on, because we're going to enter our own data using this. Put in the name for the response variable, hours studying. There's a response variable here. Choose the number of groups. In this case, we have 4 groups. Type in the names of each group, region in this case. Then we copy and paste the data above into each data box in the app. Once we do that, we get something like this. Looking at just the summary statistics, how do you think there is a difference? Do you think there is a difference in the mean number of hours spent studying for the groups? Explain your reason. Again, looking at just the summary statistics, do you think there is a difference in the mean number of hours spent studying for the groups? Explain your reasoning. Answer: there does seem to be a difference in the group. STEM majors studied an average of 18.5 hours a week, while business major studied 15.7 hours, which is almost 3 hours a week less. And this is the descriptive statistics. So the sample size, they're the same 12. The mean for the first group is 17.3, STEM 18.5, education 16.0, business 15.7, standard deviation and the standard error. Okay. Problem number 5. We will now create box plots so that we can visually access the data. Under type of plot, choose box plot. What do you predict the conclusion will be based off of the box plot and the sample means? Looking at the box plot, what additional differences and similarities do you see in the groups? The business and education majors had a similar sample mean number of hours studied per week. The STEM majors were the most spread out. The STEM had the highest sample mean, followed by the arts and humanities. You can see it here. Here's the box plots. Now for 6, we will now draw our attention to the ANOVA table, state the F statistics and the p-value. The F statistics, F is 3.76. P-value is 0.017. This is F statistics. This is the p-value from the ANOVA table. Okay. 7, using an alpha level of 0.05, what is the conclusion? Refer back to the research question and interpret the result in the context of the problem. Answer: since the p-value is less than 0.05, we reject the null hypothesis. This suggests that at least 2 means are different. So there is convincing evidence, a difference in the mean number of hours studying per week for at least 2 majors out of the 4 majors: STEM, arts, humanities, education, and business. Suppose a friend stated that the mean number of hours studied was significantly different between all 4 majors. Would this be the correct interpretation based on the ANOVA result? Why or why not? Answer: no. The ANOVA only tells us that at least 2 groups are different. It does not tell us which groups are different. And it doesn't tell us all the 4 groups are different from one another. It only tells us that at least 2 are different. Okay. Number 9. Suppose instead of an alpha level of 0.05, the alpha level was 0.01. Would you come to the same conclusion as in problem A? Why or why not? Think about it. The answer is no. Since the p-value would now be greater than alpha, we would fail to reject the null hypothesis, meaning that there is no convincing evidence to claim that there is a significant difference in mean number of study times between the 4 majors. Thank you and see you at the next video.